Let us look at equal vectors and inverse vectors. Now, concerning equal vectors, when you have two vectors that are equal, it means that they have the same magnitude and the same direction. It doesn't matter where they start, they don't necessarily have to start at the same place. In fact, if they start at the same place, one vector would cover the other. Right? We're going to look at an example. Suppose you have this vector. You move 1, 2, 3 to the right and 1 up. And you have this other vector. 1, 2, 3 to the right and 1 up. This vector AB first and then vector CD. I want to kind of dress up vector AB and CD. Let me get rid of this dot here, that came here. Alright, vector AB. Let me keep the same color and make it thicker. Good. And then I want to change the color of vector CD. Alright, to this color. And make it thicker as well. Nice. So these vectors are equal vectors. They are equal vectors. So you can say that in this case, vector AB is equal to vector CD because they have equal magnitude and direction. I could place an arrow to show from A to B, from C to D, like that. Now, let me move CD upwards. If I make them both start at the same point, you see, they cover each other. You can only see one at the top. One on the bottom is hidden. And you see that they are equal. Now let me shift them back. They are equal. Even if I put CD up here, they are equal. If I put CD here, they are equal. It doesn't matter where I put them. I could put CD starting at the origin. They are equal. As long as the directions are the same and they have the same magnitude, they are equal vectors. Alright? Now, suppose I turn vector CD around like this so that the arrows point in opposite direction. Then in that case, what I have are inverse vectors. Alright? So I would have to put a negative sign in front of this now, because vector AB going this way is the inverse of vector CD. What this would mean, since I put a negative in front of CD, if I make the negative act on it, it would turn the arrow in the opposite direction to make them equal now. Alright? But let's put back my arrow as it was before. So, you see, inverse vectors have the same magnitude but opposite direction. Alright? Opposite direction. Now notice that if I should do this, same magnitude, but guess what? They are not in opposite direction anymore. So these would not be inverse vectors. All that happens is that they have the same magnitude. but they're not inverse vectors. I would have, if I want them to be inverse vectors, I would have to put them back so that they are facing direct opposite direction. Now notice they are parallel. Once they are inverse, they are parallel and the opposite direction. Alright, so these are inverse vectors. So equal vectors have the same magnitude and act in the same direction. Equal vectors, same magnitude, same direction. But inverse vectors now have the same magnitude, but they act in opposite direction. If I should have the same direction as before and I lengthen CD a bit, then you no longer have inverse vectors. They must have the same magnitude, so I need to put back D to make the magnitude. And by magnitude, of course, it means length, the length of the line of the vector. So same length or same magnitude, but opposite direction make them inverse. But if I turn this around and then have same length, same magnitude, and same direction, same magnitude and same direction, they are now equal vectors. Alright? So they will be equal vectors now. Okay, so that was it for this video. Equal vectors and inverse vectors.